Okay, good evening. Welcome to
Math number 701.
FamilyMath 701. So we were just looking at graphs of sine and cosine, just as part of your review in auto problem solving, pre-calculus. And I asked you a question that what happens if I make a different graph using something called parametric plot, and that what that's going to do is my x-coordinate is going to be the cosine of the value we're looking at. The y-coordinate is going to be the sine of the value we're looking at. So instead of looking at these waves that go along the x-axis, waving up and down, what's the x-coordinate going to do?
The x-coordinate is going to start at it's going to start at 1, and then go down to 0, and then down to -1, then up to 0, up to 1, and then just keep bouncing from between 0 and 1.
Okay, along the x-axis. So it's not bouncing up and down; it's bouncing left and right. Okay, what's the y-coordinate going to do? Well,
the y-coordinate is going to start at 0 and then bounce up to 1, down to -1, up to 1, down to -1.
Okay, so
the y-axis.
I asked you what you thought this graph was going to look like. Do you have any guess?
Well, I know a few points that are going to be on here.
Oh, okay, that's a good idea.
The point, we can see the point 1, 0 is going to be on here.
Okay.
We know the point 0, 1 is going to be on here.
Okay.
We know the point -1, 0 is going to be on here.
Okay.
And we know the point 0, -1 is going to be. So maybe it's going to look like a circle.
Okay, I only ran it from t only goes to pi, so look at that.
Half a circle.
And if I go to 2 pi, what do you think it's going to look like?
Full circle.
By the way, is that on camera?
Yeah, it is.
It's barely on the screen. What if I go to 4 pi? What's it going to look like?
I think it'll just look like this. It'll just keep looping around itself.
Okay. So why do you think the regular sine and cosine graphs kind of go along forever like that?
Well, they're just looping. They're just equaling the same thing. Like sine, if you add 2 pi to something, like sine of pi over 2 is going to equal sine of pi over 2 plus 2 pi.
Okay.
You're just looping around the circle forever.
Interesting. So now I'm going to have just a little bit of fun with you because we can change this. Now I'm going to multiply cosine, the x-coordinate cosine 2t, y is sine t. What do you think that's going to do?
And that's just going to stretch the circle outwards, so it'll look sort of like an oval.
Okay, interesting. Let's see.
We're on it from -1 to 1.
So there's my graph.
It looks like a sideways parabola.
It does look like a sideways parabola, but it doesn't go on forever. What's happening here? I start at 1, I go to -1, and then I come back. So I'm just sort of going back and forth, back and forth.
It's weird.
It is weird. Give me some other things I can do.
Cosine of t over 2.
Alright, cosine of t over 2. Any change you want to make to sine?
No, not yet.
Okay. How about something crazy? 5t sine of 3t.
Alright. Whoa.
Yeah. I need to make these easier to understand and draw them out a little bit, but what you have going on here is you start just kind of looping around in these really crazy patterns.
Kind of like the knot project, but in 2 dimensions.
That's exactly right. And we could vary the z value here as well. We could do a 3D parametric plot varying the z value and probably figure out how to make some of those knots. It's pretty neat. The important part is that when you have cosine and sine, you get a circle. But then you can start playing with the cosine and sine values. You could even do cosine of 5t, cosine of 3t. And you get an interesting looking shape there. Almost looks like a pretzel. Anyway, that's kind of fun to play with, and you can actually make really cool shapes. Alright, I just wanted to show you that, but again, the most important thing is when you have cosine as the x and sine as the y, what shape do you get?
Circle.
A circle.